Hi everyone. So this is our research paper, adaptive NLP-based test automation framework, which will enable self-centered, you can say healing as well as aware test cases. And as the chair mentioned, my teammates, there is Suresh as well as Sai. And the agenda would be first we'll discuss about the challenge regarding test automation maintenance prices, then the core technologies, which are NLP and ML foundations, and then the system architecture, which is implementation and CI/CD integration, and then the application and results, what we see in the real world, the metrics, the challenges and future, which are like limitations and research directions, and conclusion. So as we dive into the challenge here, like test automation, we are at a breaking point right now, right? We see a lot of critical resource drain. About 50% of QA resources, as based on industry survey, reveal that test automation maintenance consumes majority of the QA team resources, uh, which effectively kind of it negates the efficiency gains promised by automation itself. Because automation initially was supposed to save time. However, using this resource drain, we are meeting that gap, or you can say not making enough profit of automation out of it, right? So what is the root cause? So tests fail regardless of actual functionality because they cannot distinguish between cosmetic UI modification versus functional changes. So it could be a very trivial change, or it could be something bigger in nature as well, right? So then we what we do basically the element repositioning versus element removal, right? So sometimes we could have a new functionality which has come and which is causing this issue, or it could be an existing functionality which has ceased to exist and it has been taken away from the application. So we go about label updates. It could be in the document object model. What we are trying to do, we remove the specific label, or you can say locator identification of properties, or it could be workflow changes, which is done with respect to the application. So the brittle test design we are talking about, like the traditional framework, rely on explicit element locators, right? We have something which we use for locating those elements using Selenium, APM, Playwright. All of those tools use element locators. So sometimes what happens, we have some hard-coded data. It could be with respect to those XPath. It could be related to those ID, name, whatever we are using here, and some procedural test logic also could be causing the issue. So we are having like we create sometimes rigid dependencies that break with every UI change, right? Every time there is a UI change, uh, we could have those locators could change, the identification properties could change, and that could result in our application automation eventually failing, right? So this false negative, which is not related to the application, this is not related to application holistically changing as such. These affect or impact the confidence in automation. Should we go for automation? Are we saving time? Are we reusing stuff and stuff like that? So what is the missing link? So the current automation, it lacks semantic understanding. Uh, Semantic by name itself, it talks about the ability to comprehend intent over implementation. So the natural language processing driven automation bridges this gap by enabling frameworks to understand what the test is supposed to achieve, not just what it is current, how it is currently implemented. We're not looking at the hows, but what here. So let's look at the solutioning here. The NLP-powered adaptive framework. It is based on three pillars of intelligent test automation. First is context awareness. Context awareness talks about understanding the intent beyond the UI. So what we are doing here, the NLP-enabled frameworks, they interpret business requirements in natural language. They extract the contextual meaning that transcend the UI implementation details. So let me give an example to explain it properly. So users should successfully complete payment when valid credit card is provided. So adapts to multiple UI implementations without modification. So what we are doing here basically, right? We had to go through a flow, entire flow, but we adapt to that UI implementation without making any modification with our specification. So that is what the context awareness talks about. Now we are talking about semantic self-healing. So what does it do? It detects the equivalent functionality. So the ML model, they detect when element serves the same purpose despite visual changes, like automatically updating the locators and flows without human intervention. It could look at the text, it could look at the functionality. It looks at mainly the how we are going to do it, the functionality, rather than the intricacies of, you can say, brittle test cases, what it used to fail before. So the traditional method, as it says, the button renamed, then the test fails. Using the NLP enhanced, we have the semantic match and the test adapts it and it passes. So the test will not fail just because of a locator change as such, right? It will fail if there is a functionality change. It should fail ideally, as an automation should catch that functionality error. So the adaptive intelligence in this case is dynamic test flow generation. The frameworks dynamically build test flows based on runtime conditions. So we have a current application state, then we have user identity and permissions. So these are the changes which are impacted by the test flows based on runtime conditions. So then we have active business rules as well. Finally, we look at the UI layout variations. So these all are tackled by adaptive intelligence and the dynamic test flow generation. So what is the resultant out of it? Like one test case handles multiple scenarios without rewriting. We save time of not writing it repeatedly. So like dry principle we use here, do not repeat yourself. So we don't repeat it, right? We just have those single test case, multiple scenarios without rewriting. Then there's proven impact, what we've seen here, like 80% of the maintenance reduction, as we see here, right? We spend hell lot of time wasting on just writing test cases, rewriting test cases, customizing test cases just to make it accustomed to the UI, right? Here we save that time. So combined with improved accuracy and coverage through their semantic understanding and self-healing capabilities. So this NLP-powered adaptive framework helps us understand as well as self-heal those test cases. Now look at the core technologies or the foundation on which it is based. So the NLP foundation is based on transformer models and semantic understanding. So transformer-based language models, what are they? So the modern NLP leverage BERT, GPT, and T5 models designed to understand language context with unprecedented accuracy. These are the models which we have been using. So the intent comprehension is process test instructions into executable steps. So initially we have a set of instruction. It breaks down into set of steps. The step in a flow manner. After step one comes step two and like that, right? So then we have the entity recognition. We identify the actors at play here. If it is a user story, we suppose like as a user, I need to do this to achieve this, right? That's a user and that's an actor which performs an action for an intended outcome. It could be a user story, it could be a user flow, it could be anything. But that is the entity recognition it does. Then we have context resolution, right? So we handle ambiguous language using surrounding context. We don't look at anything else, right? We can look at the surrounding context and we understand it. Once we understood the context, then we resolve that context by handling the ambiguous language, or you can say the discrepant language we handle using the surrounding context here. Then finally, we generate the report, right? That report should be human readable test results, which gives us a impression of how our test case fared in a particular environment and what were the changes it did, right? Initially, there was a run and it adjusted with the self-healing capability and it passed eventually. So all those details are in front of us in our eyes with detailed structured steps and screenshots as such. Then we have the relationship extraction. How does it extract the relationship? It identify the connection, like a user clicks button on a page in a particular situation to build that kind of semantic graph relationship between one object, or you can say one image or a one click or one operation to another click or another operation. It understands and then it comprehends that information. That way the graphs are related to each other and they build that semantic nature representing the application flow regardless of any surface appearance. It doesn't depend on whatever is given on the surface. As I said, the surface information could be anything which is an ambiguity which is caused by the detailed change would happen on the UI, but the functionality it remains intact. So it focuses more on the functionality rather than the trivial or fragile changes to the environment by the UI. So we look at the named entity recognition, right? NER. So this identifies the key test elements from plain English, transforming business requirements into structured test components without any manual intervention. So earlier what we used to do, we used to manually go ahead and update those locators or change those locators. And as we went through a previous slide, we ended up spending a whole lot of time. But now all of this is done automatically using this NLP models or the NLP foundation, what we're using here. The example we're talking here, like an admin user should access the reporting dashboard and filter transactions by date range. So the role here is an admin user. The UI element we are talking here is the reporting dashboard. And what action we are trying to perform here? We're trying to perform the filter transaction. And the filter type we are using is a date range. So the semantic parsing, it isolates the test concepts for mapping to the application components. It takes them away. It doesn't have any dependency on that particular UI thing. It has to look at the functionality. So the key innovation we are talking here is semantic graphs represent test case flow independent of UI implementation. What does it do eventually? It enables adaptation across the interface changes, and it is accustomed to any changes which happens as such. Now, talking about the core technologies, machine learning or the self-healing test logic, what we are talking here, we handle UI changes with smarter locators. So the machine learning, it solves the brittle locator problem. That is the main problem we're talking about here, like which results in 40-50% of extra time spent by the quality engineers. So we are solving that problem. How we are solving? Through intelligent adaptation mechanisms. So first, what we are doing similarity matching. What does the similarity matching stand for? So when the primary locators fail, the system searches for visually or functionally similar elements and automatically substitutes the best match. Okay, so there are like plan A fails, then we have plan B or plan C or plan D, like that kind of similarity matching it performs. And it looks for specific functionality, not only the UI as such. The nearby components also it looks, and how the functional flows are going based on that similarity matching is performed. Now we're talking about the probabilistic locators. Instead of rigid single rules that it has to be that particular locator, the system maintains flexible models of element characteristics, as we said. So when a change occurs, it selects the most probable match based on multiple attributes. So we have adjusting test logic, like the ML models enable adaptive testing for dynamic applications. That's where the challenge comes. Like we have a dynamic table, web table, or a dynamic page, which gets updated regularly with less respect to live events. In that cases, how do we adjust our test logic? Because in those cases or those scenarios, having a static locators can be challenging, or is almost most of the cases we have found that challenging, as well as maybe we will have a lot of discrepancies related test situation or test data as well. So those are handled automatically, adjusting the test steps based on past test execution patterns, current application state, then the user identity and permission. The role is important. What kind of user role we're using here? Then the active business process we are trying to use here, right? It could be any kind of business process we are using. It could be any domain. It could be anything, right? We could apply it across anything. Then the UI layout variations. It could have different kind of UI layout variations. It could be an HTML5, it could be a Vue.js, it could be React, it could be anything, right? We need to ensure that it has that logic capability when we're moving from, say, from example, a web application to a native application, or a web to a mobile application, right? Those kind of changes, navigations, all those are handled tactfully using this test logic adjustment. So what does the result? Is the result is completely a one test handle multiple situations without rewriting. That's the goal, what we are trying to achieve. So the self-healing success rate, as we have seen with respect to UI change recovery, is about 92%. So we are looking at the system architecture basically here, the framework architecture and CI/CD integration. We have a three-component architecture structure. First, we have the NLP specification parser, which reads natural language test instructions and converts them into structured components. The structured components are what? They are the test names, steps, expected outcomes, and data requirements. As a normal test case would have, right? We have those lists. And where does it store it? It stores it in semantic graph format for searchability, so that we can easily search those and parse those specifications in accordance. Then we have the smart test execution engine. What happens here basically? It uses machine learning to build test flows dynamically. Okay, just double quoting the words, build this test flows dynamically because it adapts to the application behavior. It selects appropriate elements and data and verifies the expected results. So what happens here? It basically tracks execution data for continuous improvement. Okay, so then we have finally the continuous learning system. So what does continuous learning system means? As in our own life, when we fail, we learn, right? So in this case, although the test failed, the system learns from detailed failure data, what failed, why it failed, which UI components were involved, and which adjustments succeeded. So it learned from that and became resilient. So the next time it understands that and it tries to accommodate it and adjust it based on those changes. Then we are talking about the CI/CD integration pipeline. We have a DevOps pipeline integration. We have some trigger points. So the test auto trigger from the specification changes. Then the code commits itself or the schedule runs. We can have GitHub actions. We can put it in a CI/CD YAML file or trigger those actions. We can have any way of doing it. But that those trigger points, they introduce those specification changes and the code commits happen accordingly. Then we have the feedback loop. So the results or the feedback, we put that into the continuous improvement cycle, like refining the ML models. Every time we have a new code check-in or commit, those kind of feedback mechanism comes back. So that is what the CI/CD stands for, continuous integration and continuous deployment with regular feedback. So we refine those ML models on a continuous method. So we perform the deployment, seamless integration with existing CI/CD tools, Jenkins, GitLab, CI, etc. So these are the key advantages which you are facing out of a CI/CD integration flow. Now, looking at the application and results. So in the real world application and performance metrics, we're looking at enterprise web application. So large enterprise system with frequently updating UIs benefits significantly from the NLP power testing, as you see, because the more complex the application, it's difficult to test. So 75% of the maintenance reduction using this kind of approach, we have dynamic decrease in the manual test adoption and the 45% coverage increase because we spend less time in solving trivial issues. We spend more time in having adequate coverage for the test case. So more comprehensive test scenarios are covered. So 92% self-healing accuracy because it doesn't depend on the nuances of the UI elements, rather functionality. So we solve those specific validations in production environments with due diligence. So industry, which industries are impacted, financial, everything. It could be any industry, but we are talking the sample case about a financial services platform case study. I'm just talking about here. So the mobile application testing also helpful here, where mobile testing faces unique challenges due to device diversity and OS. We know the device fragmentation, like across iOS or Android, as well as across them we have like tablet, as well as iPad and different kind of variants, etc. So those key challenges are addressed with a wide array of device specification. And in Android, we know there are different mobiles like Samsung, Google, whatnot. So those wide array of device specifications are tackled using this. The multiple OS version, iOS and Android, and screen size resolution is also, we could, in mobile, it could be 6.5, 5.5 inches, and in tablet, it could be a different 10-inch or 11-inch, whatever we are talking about here. So all those variances are taken care of here. The UI layout differences are there when it changes from one layout to another layout. So the NLP solution here is automatically adjust the test logic to accommodate device characteristics, like ensuring reliability across the entire mobile ecosystem. So we don't have to change those, you can say, designated locators for specific document object model. As such, we can adjust it by self-healing. Now, moving to the API testing from behavioral driven development. So those business requirements described in plain BDD style language automatically converts to comprehensive API tests. So there are more of kind of specifications which are initially there, like example specification, like user transfer fund between account. So we have API endpoint identification, request response validation, there are error scenario coverage, negative scenarios, as well as business rule validation. All of this can be catered smooth and seamlessly using this. So the benefit we get out of is ensuring every API specification promise is verified automatically. The technical challenges and system limitations we are talking about here, the data as well always has been a challenge. So training data requirements, the NLP models require substantial labeled training data to perform effectively. So the challenge we see here basically starting in a new domain demands significant investment in time, resources, and knowledge of those data systems, right? So then what is the impact here? Basically, we have initial deployment cost may be higher than the traditional automation frameworks, but the mitigation we have here basically transfer learning and pre-trained models which reduce domain-specific data needs. We are not dependent on any specific domain for the data challenges. So the model, how does it model explain itself? Like many ML models operate as black boxes, decision reasoning isn't always transparent. So that why did the test select itself? Those kind of challenges we need to deal with how the model explains itself, right? So then we have system complexity as well. We integrate the NLP models with ML systems and traditional platform. They create complex architectures, right? The complex architectures are like multiple interconnected components, dependency management complexity, and debugging difficult. That increases with time, right? So those kind of requirements, they're thoughtful design with robust monitoring and alerting. Those are taken care by using this NLP ML model. The domain adaptation, it can be through any domain: healthcare, finance, it could be media and streaming, it could be SaaS, any domain. It can apply to any of those domains, right? So now the research opportunities and future developments we are talking about, like visual understanding, we will add computer vision to NLP, so that will give an added advantage where we just not understand the code, but also see what users you actually see on the screen. So we look at the visual element beyond the DOM even. Then the layout and design pattern detection, screenshot-based validation, cross-model semantic understanding. Those are the visual understanding we cater, or we plan to see more growth in that space. Then automatic test case generation, we look at the input, the app documentation, then the all AI comprehends those. Then generative AI, of course, is used to build complete test suite by reading the application documents. No manual input is required. So though that automatic test case generation, creation, maintenance, those things can also be taken care of. There is a lot of research still going on in that field, and also advantages of that and pros and cons of that still been discussed. So we're looking at kind of reliable way of handling those automation test case generation. So write one test everywhere. That's what the goal is. Like intent is basically across web applications. The same set test case can be used across web applications, mobile, desktop applications, API endpoint, just to have more reusability. The basic goal of, or basic currency of automation is to have more reusability, right? And looking at the intelligent failure prevention, the ML models predict and prevent failures before they even occur, right? More of prevention, right? Prevention is better than cure. That's what you find defects early as per so the to reduce the cost going forward. That's the basic goal of any automation approach. That's what is in the genes of this. Basically, it tries to handle that beforehand. We look at the pattern recognition from historical data, look at the risk factors, and all those challenges we deal with even before that challenge. We comprehend those challenges even before they occur, right? So just to prevent them from happening in future. These are the research or future developments which are happening. So the future of intelligent QA, what we are looking at, the novel framework architecture. It's combining transformer-based semantic analysis, name-based and entity recognition, and relationship extraction for comprehensive test case generation execution. That's what we are doing it. And adaptive self-healing, as we already talked about, automated detection of UI changes and dynamic updates to test locators and flows without even human interaction. The validated enterprise performance, we're looking at 80% maintenance of reduction and 92 self-healing accuracy and 45% coverage in the improvement. So those are the best key contributions we're looking at. We're looking at paradigm shift as well, right? NLP marks a fundamental transformation in test automation philosophy. We're looking at a traditional approach where we look at rigid, fragile systems that break with every UI change. Now we are looking at an NLP model where we intent understanding and self-adapting, continuously learning system. We learn from our mistakes and improve. That's what we are trying to do. The strategic impact here is reduce test maintenance overhead, increase focus on quality strategy. Those are all the benefits of automation we are trying to reap here, right? So using all those benefits and fast adaptation to software changes. So that is the CI/CD process as we get the feedback and we process and then improve from those processes. The competitive advantage in delivery speed, as the right that you can say the faster we gain those issues or our challenges in hand, the market it faster, right? So the marketability is done expedited speed, right? So that's in short or in a nutshell about what are the learnings basically from the NLP based automation and how it can transform your QA process. So if you guys have any questions or concern, please reach out to us. These are our email IDs, and we are also in LinkedIn. You can search us and send out a request. And thank you for your attention. And let me know if you have any questions as such.